Okay, we're doing 5.3, number 36. So basically we're working with y equals 3 to the x as our parent function. If I make a table of that, 3 to the 0 is 1. So if x is 0, y is 1. If x is 1, 3 to the 1 is 3. And 3 to the 2 would be 9 up off the page. And if I go to the minus 1, that would be 1/3. Minus 2 would be 1/9. And so we've got a curve that looks like this. And the points are 0, 1, 1, 3, and minus 1/3. And minus 2, 1/9. And now they ask you what graph would look like this, where it goes through 1/3 and then goes through 1, and which equation? Well, the 1/3 was supposed to be here. Looks like this graph is just the original one moved over 1 that way. And so to move something 1 in the x direction, you would subtract 1 from the x. So this would be y equals 3 to the x minus 1 moves it plus 1. So that is F. Next one was 38. And now this graph looks like it has the asymptote there, it goes through the origin, and it looks like this. So if we took our original graph and flipped it over the original graph and flipped it over the x-axis, it would be down here, which is kind of what this looks like, except moved up 1. So how do you take and flip it over? Well, you change it on the outside of the parent function. You'd put a minus. So we'd have y equals minus 3 to the x. But then if we to the x, and then if we want to move that up 1 to have, instead of the x-axis being the asymptote, but 1 being the asymptote, we'd have to move the whole thing up 1. And that looks like H. And then next one is 40. And 40 looks like this thing just flipped down only. So that would be y equals negative 3 to the x. So that is C. And 42 is the next one. And 42 looks like this graph, which goes through 3. Looks like it's flipped over this way, so that which would be like this, and then moved 1 over, so it's like there. So how do we flip it over the y-axis? Well, we do that by putting a negative on the x. So that would flip it over and make it go here. And then if we want to move the whole thing over 1, we'd have to add 1 to the x, or subtract 1 from the x. So that looks like none of those directly. So how else could we get it to do that? Let's see. Gotta look at it again here. We're doing number 42. Oh, no, there it is. And 2 is at 1, 9, no, it's at 1. 1, so it's moved over 1. And it's got a negative on it. So this would be the same as 3 to the minus of x plus 1. And I don't see that in any of these here. But these are added exponents, so I could split this up. This is minus x plus a minus 1, so we could write it as 3 to the minus 1 times 3 to the negative x. And 3 to the minus 1 is 1/3. So 1/3 3 to the negative x. Do we have that in here any place? I don't see that either. Well, that's what it should be. Now there might be another variation of it, but that's the way I see that one. So, okay, I don't know why it's not there. All right, 49. 49 says we have f of x equals 3 to the minus x minus 2. And we're supposed to use the transformation. So we've got this same 3 to the x parent function. What's happened to it with the minus x flips it over the y-axis, so it would then go this way through 1, and at 1 it would be 1/3, and at 2 it would be 1/9, and at minus 1 it would be up at 3. So it looks like that. So that takes care of the minus, and then the minus 2 moves that whole thing down 2. So that would go down to here, and it would go up 1, 2, 3 over 1 and be right. Oh, from here it's up 1, 2 over 1. 1, 2 over 1, so it'd be right there. And the asymptote, instead of being there, it'd be down 2. So that's what that one would look like. 49, the next one is 54. 54 says f of x equals 1 minus 2 to the negative x over 3. So the parent function is here is y equal 2 to the x. Let's take a look at that. 2 to the 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4. 2 to the minus 1 is a half. 2 to the minus 2 is 1/4. And it looks like that. That's our parent function. Now let's take care of the x transformations. So I have a negative on the x, which is going to flip it over the y-axis. So now it's going to go this way. And then I've got a third on the x. So that makes you think it would be a third as wide in the x, but it makes it 3 times as far in the x. So it's slower doing this. So instead of going down to a third at 1, it'll be down to a third at 3, and down to a 9th at 6. And instead of being at minus 1, up at, a half and a quarter, at 6. If we go this way, instead of at minus 1 being at 2, it would be at minus 3 times as far. At minus 3, it would be at 2. So it's much stretched out this way. That would be this. And then we've got to flip it over the y-axis because of the negative, so then it's going to be stretched out this way. And then we got to move it up 1. So it's going to go stretched out, look right there. So it would be, the asymptote would be moved up to 1. It would go through 0. And at 3 over, it'd be at a half. At 6 over, it'd be at a quarter away from the asymptote. And 3 back here, where it would have normally been up to 1, 2 from the asymptote. So that's what this would look like. 54, that was a pretty complicated one. Okay, now let's do, next one is 55. A new section. 55. Begin with y equal e to the x and then draw f of x equals e to the minus x. So that's just the negative on the x, which is a reflection over the x-axis. What's this look like? E to the 0 is 1. E to the 1 is e, which is 2.7. 1 over e is 1 over 2.7, which is a little bit smaller than a half. And so this is what e to the x looks like. And so e to the negative x would take and just flip this over the y-axis. So this point would be over here, this point would be over here. So there is this one. That's 55. 68. It says solve this equation. All right. So put this down. 68 is, we got to solve 1/4 to the x equals, whoops, which one am I doing? 68 equals 1 over 64. Well, the common base in here is, we could go with 1/4, but this is 4 to the minus 1 to the x. 64 is 4 to the 3rd, and it's in the denominator, so this would be 4 to the minus 3. So we have minus 1x equals minus 3, so x must equal 3. But you have to know that 4 times 4 is 16 times 4 is 64. Okay? That's 68. 75. 75 says solve this one. 3 to the x squared minus 7 equals 27 to the 2x. Well, the common base in this is like 3. So we have 3 to the x squared minus 7 equals 3 to the 3rd to the 2x. 3 to the 3rd is 27. So 3 times 2x is 6x. So 6x has to equal x squared. And since we've got a quadratic, we want to make it equal to 0. So we're going to have x squared minus 6x minus 7 equals 0. You can use the quadratic formula, but this factors to x minus 7x plus 1. That makes plus 6x minus 7x is minus 6x, and this makes minus 7, and this makes x squared. So x equals 7 or negative 1. And you can check those, both of those will work. That's 75. And then finally, 83. 83 says if 4 to the x equals 7, what does 4 to the negative 2x equal? Well, this would be 4 to the x to the negative 2. Because when you got a power to power, you can multiply them. And 4 to the x is 7. So this is 7 to the negative 2. Well, the negative would make it 1/7, and 2 would square it. So 1/7 times 1/7 is 1/49. They just want you to practice power rules. And that's it for 5.3.